Now, I'll give you a 5-minute background just on the Schematic Manager, so you know what things are. The Hardware Manager, you probably want to come in here sometimes to try and track things down.
Yep.
So here's your rack, universal rack. It's rack 0. There's your PLC. Your PLC is always in slot 2.
Yep.
And for this PLC you can only have up to 11 slots, which is fine. Then you get extensions. So, and it's got PTP port, you got digital input and output card, and analog input and analog output card.
Yep.
And if you're really stuck and you've got no drawings, you've got wires going in and stuff, you come down here and you can see that my analog input start at input 752 and finish at 761 and 752 and 755. So when you're looking for your output the other day, you probably had QW, one of those numbers.
No, yep.
Or something around there.
Yep.
So, and if you want to add stuff, you come over here. It's a 300 station. So there are CPUs, digital input, digital outputs, but that's just to find actually the full part number.
Yep.
Type it in, find, search, and then you can drag them into the racking where they physically are.
Is that really like all there is to do as far as setting up another card? Like, is that all we have to do?
Yeah, pretty much. So if we went to,
check and say an analog output card.
So
we do that for example, because I've got a feeling I might need to actually do that.
Yep. Just trying to find out what this one is. Actually, unless is that an additional card or is that on the PLC?
No, it must be additional.
It's like 2.3. You find your card. Yeah, here's analog inputs and analog outputs, and where it's green is where you can drag it to. So we get a 4 in and a 4 out card. Drag it over to 6, and it's in 6.
Yep.
And it automatically allocates some addresses for it. You come in and you can change the where you want the address to be, because if you might want it to start after these, but generally you can just leave them there. And then each card's got its own settings and stuff. So this one's got RTDs and PT100s. So obviously it's a temperature input card, so you probably won't get that one of those. So we'll just delete him. There. And this is where you probably set up a lot of your PLC stuff.
Yep.
So give it names, and clock memory is a good thing to know. So at memory byte 255, there's clock memory. So there's like generated pulses or clocks. So 1 hertz, half a hertz. Yeah.
Yep.
And that's there. So pretty useful when you're doing flashing lights and stuff. Not doing nothing else too much fancy here. There's no password on it, which is good. You can have it so you can't download, or you can have it so you can't read or download.
Without entering the password.
Without entering the password. And we won't go into drops and stuff. So you'd always save and compile hardware down, and you download that one. Yeah, it has to stop the PLC.
Yeah.
And if it's a safety PLC, it stops it. Essentially, it's like an e-stop as well, so that kills that. This little symbol here is configure network, which I had.
Which is what we were in the other day.
This stuff here doesn't actually I don't think you can actually download it, but this downloads Hardware Manager, I believe, as well. I'm not too sure. Only parts of the Hardware Manager. So I never really download from here. I always do the edit, save and compile, because most of these settings are just for the PC. I don't know how I'm going to get online to the PLC. close hardware manager. And that's the PLC. This is the programs. So this is how you get to symbols. So it's a bit hidden because it doesn't come down here in the list. So you got to be. So if you're going to symbol, this is the symbol table. So depending on what they've done, go address. Do you want to? You can't. It's just sorting it so that you can't put it back into this order. That's I don't care. So here's all the DBs, FCs, inputs.
So DBs are data bit.
Data box.
Data box.
So you have. So if you got to write code in, you can either write it in like an FC, and that's just like a plain old. You write your code in there as any other file, and you can access data. Like your main and stuff, well not main, but general code would be an FC.
Yep.
A FB has a DB, so if you want to write code that's used again and again and again and again, so one example is like a winding head of a machine that winds up fabric. That's what I used to work on. It's got 8 heads, they're all the same. They all have the same code. You can write one block of code for FB, so that'd be FB1 and DB2, and then
FB2.
use FB1,
DB3.
DB3,
Yep.
sort of thing. And so for this, when this function block code is executed, it stores all the values in this DB and reads all the values from that DB.
It's the same as like a block of data in well.
Yeah.
Yeah.
I'm not sure the terminology. So that's what those are. FC inputs. They got sort of lazy. They've called input 0, input 0.
Yep.
A bit of English there.
Yeah, I've changed a few of them.
So you just change. So it's pretty safe to change the comments. That won't break anything.
Yep.
And then you got your memory.
So internal bits.
And you got to be careful because you can say. So here they've got M0.7.
Mm-hmm.
Right? And here they've got memory double word 0. So this one's taken up 4 bytes. So they're accessing the whole 4 bytes,
Mm-hmm.
but they're also accessing the 7th bit in that whole thing as well separately.
Right.
So you can get really caught out. You say, oh, they're only using bit 7, I'll use bit 1, I'll use bit 2 if you look at this list. But they're actually using the whole double word.
Yep.
Which is why I got you to go to reference data and said stay away from the blue bits.
Mm-hmm.
And all your outputs. And they can use an output and not declare it, and it won't come up in this list. So you might say, no output 2.0, A2.0, A and Q are interchangeable for German.
Yep.
And I and E are interchangeable as well for inputs.
Yep. So would we be able to find, say, the analog outputs in here?
If they've defined it.
I don't think.
I don't think they have. No. So we'll define that when we come across it, which will be good. So we'll try and. Do you know where an analog output is?
Yeah, FC4.
MC4.
So this is where I've done most of my changes. I've had to go through here and pretty much translate all of this.
Yep. I guess it's going to have like a move or something.
Yeah, it's right down. So this is it here.
Okay.
Wasn't too. And if you go down a little bit further, keep going. I think this is the actual modulation giving the speed reference to the drive.
What are they doing? With auto selected, display one cadence goes to, that's just a temporary variable.
Okay. I was trying to work out what these L ones were.
So that's just temporary, it's real. So there's, instead of declaring more memory, they've got temporary variable there.
Just use that bit.
So they write to it and they just read it straight away.
Yep.
They multiply it by